Alright, to finish off today we're going to be talking about quotients, dividing over some fractions here. If we are dividing two numbers that have the same base, and they are to a certain power, we can subtract the exponents. So for instance, this would be 3 times 3 times 3 times 3 times 3, all over 3 times 3 times 3. And since we're multiplying, we can do some factoring.
Owen rules is go to the cafeteria. Owen
This
rules
will
to
be,
the cafeteria.
technically there's a times 1 down here, so this is like 9 over 1. Or I guess I could say 3 to the second over 1, or just 3 to the second power. Which means I can just take 5 and 3, as long as these bases are the same, and subtract them to get 3 to the second power, which is what this rule says. So, some examples of this. So if I look at A very quickly, 3 to the 8th over 3 to the second, this is going to be 8 minus 2. So the opposite of when we multiply things that have the same base, and we get 3 to the 6th power. Letter B actually shows why anything to the 0 power is 1, because x to the 5th over x to the 5th is 1, right? Because we divide the same thing by the same thing, we get 1. But if I look at x to the 5 minus 5, I get x to the 0, which equals 1. And we know that anyway, but that's what it comes out to. And then you can see in letter C, we do a couple different, there are a couple different things we got to do. So we might have to do this first. So we got a to the 5th, b to the 9th, and then I've got a to the 1st and b to the 1st, but that's all to the 4th power. So I've got to use my power to a power rule. So this is a to the 4th, b to the 4th. And then I can do some subtracting here. So 5 minus 4 is a to the 1st, and 9 minus 4 is b to the 5th. So a times b to the 5th power would be the final answer there. Same deal here, just be careful with if they don't show you a power. So here I like to think about, okay, well how much more do I have on top than I have on bottom? So for instance, if I look at 2 to the 3rd and 2 to the 1st, I have 2 more 2's up top. So that stays 2 to the 2nd. If I look at my 3's, I've got 2 more 3's on the bottom than I do on top. So 2 3's will cancel, leaving me with no more 3's up top. And then same thing with the 5's. I've got 2 more 5's up top than I do on the bottom. So 5 to the 2nd. So that's what we could do. The other way to look at this would be, so we could leave it just like that, or even simplify further. If we did a straight through subtraction, 2 to the 3rd and 2 to the 1st, that would be 2 to the 2nd. 2 minus 4 would be 3 to the negative 2nd, and 7 minus 5 for the last one would be to the 2nd. And then we would just have to move this to the bottom. So we would still get the same thing. We can do it that way too. Alright, what happens if we have a quotient? Pretty much same deal. This means 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. So we just distribute that, and we have 2 to the 3rd over 3 to the 3rd, and we can simplify from there. Alright, so here's what this looks like. This is 3 to the 3rd over 4 to the 3rd, because these are both to the 1st power, so I can take 3 times 1 and 3 times 1. If I look at B, just remember that 2 is to its own power, so I would do 2 to the 1st, or 1 times 3, so that's 2 to the 3rd. Power to a power, x to the 3rd, so 3 times 3, that's x to the 9th. And then 3, these are both to the 1st power, so y to the 3rd, z to the 3rd. Kind of some crazy stuff going on there, alright? What happens if we have a negative power of a quotient? So here I'm just going to look at the rule right away. You can flip the entire fraction. So you can see here we've got 2 to the 3rd all to the negative 4th. You can flip the inside and then change it to the positive 4th. And the reason for that is because if we distributed this, negative 4 times 1 would be 2 to the negative 4th, and negative 4 times 1 is negative 4, and then both of these are going to switch anyway because they're not happy where they are, and you get 3 to the 4th over So if it's a negative exponent on the outside of a fraction, you can flip the whole thing and it'll become positive. So just a couple quick examples here. I'm not going to do C. We'll talk about this one tomorrow in class. But real simple fix here for A is I could say, well, this is the same as 5 over 2 to the positive third, and then do my distributing here. So 5 to the third over 2 to the third. Same deal with B. I can say now y to the second over 3x, and now all this is to the positive 3. Just remember, so y to the 6th. Remember that 3 or any number has its own power, so 3 times 1 there will give me 3 to the third, and then x is to the first power as well, so x to the third right there. And that's not the only way you have to do that. Just for another quick reference here on B, and then I'll be done. We could have distributed right away, taken negative 3 times 1, so that's 3 to the negative third. Negative 3 times x to the first, that's negative 3. And then times 2 there. And then everything's going to switch places anyway, which turns into that in the first place. So. Alright, so that's all I've got for this. Sorry, it's a little bit longer tonight, but I had a lot to get through. So, we'll see you tomorrow.